Black holes have fascinated astronomers for centuries, or at least since they stopped thinking the sun was a black hole. Seriously, there were some dark ages. But we here now, and these dark pits in our universe are still just as mysterious as ever. These colossal cosmic entities continue to reveal new secrets about their nature and existence. In this video, we'll explore what a day in the life of a black hole looks like. So fasten your seatbelts because we're about to take a wild ride into the heart of a black hole. But before we do, make sure to subscribe so you never miss out on new updates. Be among the first to know when we release our latest videos. And while you're at it, hit that like button to show us you approve of our mission to democratize science. What exactly is a black hole? To answer that question, let's start with something simple. What's the opposite of a black hole? Well, that would be a white hole. Just kidding. White holes don't exist, or at least none have been proven to exist yet. But imagine a black hole that spits stuff out instead of swallowing it. That's what a white hole would be like. To understand black holes, we have to talk about gravity. You may remember Newton's famous apple story, but did you know that gravity was discovered long before Isaac Newton? It was observed by ancient civilizations who noticed that objects fell to the ground when dropped. It wasn't until the 17th century that Sir Isaac Newton developed his theory of universal gravitation, which explained how gravity works. He proposed that every object in the universe attracts every other object with a force that depends on their masses and the distance between them. This discovery revolutionized our understanding of the natural world. Fast forward a few hundred years and we have Einstein's theory of general relativity, which describes gravity as a curvature in spacetime caused by massive objects. This means that massive objects distort the fabric of spacetime around them, creating a kind of gravitational pull. Think of it like a bowling ball on a trampoline. The ball creates a dip in the trampoline's surface, and anything that gets too close will fall into it. Similarly, massive objects like black holes warp spacetime around them. But unlike a bowling ball, black holes warp spacetime so much that not even light can escape their gravitational pull. So what exactly is a black hole? Simply put, a black hole is a region in space with a gravitational pull so strong that nothing, not even light, can escape once it crosses a certain point known as the event horizon. The event horizon is the boundary of the black hole, and it's the point of no return. Once something crosses the event horizon, it can never come back out. This happens because the gravitational pull of the black hole is so strong that it tears apart anything that gets too close, stretching and crushing it until it's completely destroyed. It's important to note that black holes aren't actually holes. They're incredibly dense objects with a lot of mass packed into a small space. The immense gravity of black holes is due to the fact that their mass is concentrated in a very small area. The larger the mass of a black hole, the greater its gravitational pull, and the larger its event horizon. Now that we know what a black hole is, let's talk about what it looks like. Unfortunately, we can't see black holes directly because they don't emit any light or radiation that we can detect. However, we can observe the effects they have on nearby matter, such as stars and gas. When a black hole is near a star, its gravity pulls on the star, causing it to orbit around the black hole. We can see this movement and use it to infer the presence of a black hole. Another way we can detect black holes is by observing the light from objects as they pass in front of it. As the object passes in front of the black hole, the gravity of the black hole distorts the light coming from the object, making it appear brighter than usual. This is known as gravitational lensing. The event horizon is not a physical thing, such as a wall or a membrane, but rather a boundary in space where the gravitational pull of the black hole is so strong that nothing can escape. When a black hole is formed, its event horizon is very small, but as it grows, the event horizon expands as well. The size of the event horizon is known as the Schwarzschild radius. This is the minimum distance from the center of a black hole at which the escape velocity equals the speed of light. Escape velocity is the minimum speed an object must reach to escape the gravitational pull of a planet or other massive object. In the case of a black hole, the escape velocity is determined by the Schwarzschild radius. If an object is beyond the Schwarzschild radius, It cannot escape the gravitational pull of the black hole and will eventually cross the event horizon and be destroyed. Let's imagine you're standing on the edge of a black hole. What would you see? As you approach the event horizon, you would see the sky become filled with stars and galaxies. This is because the intense gravity of the black hole would cause light to bend around you, making it seem as though the universe itself is being distorted. As you get closer to the event horizon, the light from distant objects would become more and more distorted until it was almost impossible to make out any details. Eventually, you would see a bright, featureless disk of light, the accretion disk, which is a region of hot glowing gas and dust that forms around a black hole as it consumes matter. As you continue to approach the event horizon, the brightness of the accretion disk would increase until it was blindingly bright. At this point, you would be very close to the event horizon, and the gravitational pull of the black hole would be extremely strong. If you were to continue any further, you would be pulled into the black hole and crushed to death. As you approach the event horizon of a black hole, time would appear to slow down. This is due to the effects of gravity on time, as described by Einstein's theory of general relativity. As you get closer to the event horizon, the gravitational pull becomes stronger and stronger, causing time to slow down. From the perspective of an observer far away from the black hole, someone who ventures too close to a black hole would appear to be moving very slowly. This means that as you approach the event horizon, time would appear to slow down to a crawl. Eventually, if you were to reach the event horizon, time would effectively stop. This is because the gravitational pull of the black hole is so strong that it prevents any light or signals from escaping. This means that anything that happens beyond the event horizon can never be observed by an outside observer. Black holes are truly fascinating and mysterious objects in our universe. Their immense gravity and strange properties have captivated scientists and space enthusiasts alike. While we may never be able to directly observe a black hole, we can study the effects they have on other objects in space, such as stars and gas. By doing so, we can learn more about these mysterious objects and better understand the workings of our universe. Thank you for joining us on this journey to the heart of a black hole. We hope you enjoyed learning more about these incredible cosmic entities and the strange effects they have on space and time. If you want to learn more about black holes or other fascinating topics in science and technology, stay tuned for our latest videos. And don't forget to hit that like button and subscribe so you never miss out on new updates. Until next time, keep looking up. Did you find this video informative or enjoyable? Then please give us a thumbs up. Also, don't forget to subscribe for more amazing videos.